Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to discuss the concept of memory management. Myself Krunal Panchal, your instructor. Today's lecture agenda is to understand the basic concept of memory management. As you know very well, memory management is one of the functionality of operating system. So before going to discuss memory management, let us discuss the different components of computer system with respect to basic aspects. So if you recall, our process management chapter, and process management is again one of the functionality of operating system. Okay, in which we have discussed about CPU. Okay, so if you want to categorize, or if you want to find out or identify the performance of any computer system, so you cannot consider CPU only for that purpose. Not only CPU, but also you need to consider the memory of that system, because if you do not store the programs or cases softwares in memory, there is no meaning to discuss the further things. Why? Because if you do not able to, or if you are not able to store that data in a memory because of insufficient space, how the hell you can think about it, the performance of that machine? Yes, so that is the reason why the performance of any computer system not only depends on CPU as well as it depends on memory. So both these components are important, okay, to categorize those systems into different categories. So in this particular session and chapter, we are going to discuss about memory module. So let us discuss memory module in detail. So as far as memory is concerned, so there are various criteria that we need to consider. The first one is size. Means the size of memory, as I told you, is very important. If you do not have enough size to store certain programs for execution, so CPU would not be able to execute that program, because you do not have the space to store that program into a memory. Once you store that program, then and then that program can be executed in the CPU. So size is very important criteria. Means if you want to have the good performance of your computer system, you should have enough size of memory, or it is a large size of memory. Yes. So what is the desirable property in terms of size? So size should be large enough. Okay. So it means what? It should be more. So that is desirable. Second criteria with respect to memory is nothing but access time. So what is access time? Means if you want to search any element or data from the memory, so that searching or that access time should be faster, because according to that is nothing but a response time, we can say. According to that criteria, we can categorize that system into good, bad, or we can say average category. So access time is very important. And what is desirable as with respect to access time? So it should be low. So access time should be low. If it is low, in that case the performance of the system would be good, or you can say sufficient, or you can say capable enough. Okay, so the desirable property, the first desirable property is size. It should be high, second desirable property with respect to memory is access time. That should be low. Okay, because if searching time is fast, definitely that system would be more efficient as compared to others. Okay, and the third important criteria is nothing but per unit cost. Per unit cost means what? Suppose if you want to have, say for example, 1 GB of memory, or we say 1 MB of memory. So how much cost it require to have that memory? So again, it is important criteria. So what is the desirable property as far as per unit cost is concerned? So per unit cost should be less, obviously. Okay, so these are the very important criteria, okay, or we say desirable property of memory. Fine, but there is one problem. We have categorized layer size should be capable enough, access size should be small, per unit cost should be low. Yes, but out of these three property, or we say parameters, or we say criteria, some of the criteria are contradictory in nature. Like if you increase the size of a memory, definitely the per unit cost would be reduced. But if you increase, so means what, these size and per unit cost criteria can be achieved simultaneously. But what about access time? So if you increase the size of a memory, definitely the searching time would be more. And what is expected? The access time or this searching time should be less. But in this case, we are getting high access time, and there is nothing but one problem when we are dealing with memory, because we want all these three criteria, okay, simultaneously. But out of three, we can achieve only two with the help of single type of memory. So how we can solve, or how we can achieve these three criteria simultaneously? So for that, we need to use the concept of memory hierarchy. So what is memory hierarchy? So one important concept we need to understand to achieve these three criteria simultaneously. So far we have discussed a single type of memory, but now if you want to achieve this size, access time and per unit cost simultaneously, so you need to have the hierarchy of memory. Means what? Two types of memory you should have. One is secondary memory, or we can say it is nothing but hard disk, and second one is nothing but main memory. So main memory is nothing but temporary memory. It is nothing but ROM and RAM. Okay, and secondary memory is nothing but permanent memory. So by having these two type of memory, how we can achieve our objective? So let us discuss that stuff. So we need to, by having this main memory come into the picture in this particular figure between CPU and secondary memory. What is the significance of main memory? So you know very well, secondary memory size is very large as compared to the size of main memory. You know these things very well, because in market we have 1 TB of hard disk is available, but as far as main memory is concerned, you will have 8 GB of RAM or 16 GB of RAM is available. So you can see the vast difference between these two type of memory in terms of storage space. Yes. So by having these different size of storage, how we can achieve these three criteria simultaneously? So we need to use the concept of locality of reference. This is very important concept and very important definition as far as your examination point of view. So what is locality of reference? So you know very well, the execution of any program. So what is program? Program is nothing but set of instructions. So any program, if you're talking about, if it starts its execution, so it generally it executes in a serial fashion, or we say in a serial manner. Means if a single program contains, we can say, 1,000 instructions, and right now it is executing 20 instruction. So what is the probability of next instruction to be executed? That is 21, because in general the execution of program in sequential manner. So that is the reason why we can say that the highest probability to execute the upcoming instruction is nothing but 21st instruction, as far as that program is concerned. So what we can do is, if you know, if program is executing and if you know the upcoming instructions would be executed in the CPU priorly, so what we can do is the upcoming instruction we can prefetch and store into a main memory, so that we can execute that program fast. How? Why the execution would be faster in this case? Because in the case of main memory, the size is limited, as I told you. Yes, so if size is limited, the access time would be fast. Yes, but in the case of secondary memory, if size is very large, so definitely the access time would be very high. Yes, so these two things are contradictory. So that's why we introduce one small amount of memory called main memory, so that we can achieve three criteria simultaneously. So by introducing main memory concept, what we can achieve, we can achieve less access time. So by having these three criteria, because the execution of program generally it is in sequential manner. For example, suppose if you are watching a movie, so definitely you are watching movie in in a sequential manner. Yes, you cannot watch that movie in a random fashion. Yes, so same way program execution generally would be in a serial manner. Okay, so upcoming instructions. So based on this locality of reference, we can achieve the less access time, because that prefix instructions we can store in the main memory, and CPU can directly deal with the main memory to execute the upcoming instructions from it. Okay, so by having this memory hierarchy concept, what we can achieve? We can achieve less access time, because we have introduced main memory concept. Yes. Second, we can achieve uh, the large enough size because of secondary memory we have, because size is very high as far as secondary memory is concerned. So if you want to store more number of programs, you can easily store it in. Yes, then the third criteria is what? Because of secondary memory we can achieve less per unit cost. So two criteria, per unit cost and size, we can achieve with the help of secondary memory, and less access time we can achieve with the help of main memory concept. Yes, so by having this concept, or we say memory hierarchy, we can achieve these three desired criteria simultaneously. You can you can compare this main memory and secondary memory concept of this concept with real life situation as well. Suppose in real scenario, suppose if you want to purchase, or if you want to say for example buy one shop, so what you will do, so you cannot buy, or you can say purchase a large size of shop in main market, because the cost would be very high. Yes. So if you what you can do is, if you want to achieve all these criteria simultaneously, so what you can do is you can purchase a small size shop in the main market, and what you can do is you can purchase one godown in the backyard. So if you purchase the godown in backyard, definitely the cost would be low in that case. And if any customer come into your to your shop to require some items, or you can say product, so you can easily give that items, or you can say product to your customer by using your small shop. Means what, access time would be very fast in this case, because that item is available in the uh, main market. So you don't want to go to go down and get that stuff and give it to the customer. Yes, so the access time would be reduced, the cost would be reduced in this case. Yes, so definitely if such type of requirement come into the existence, like if any customer require uh, a particular product in say for example large number, same type of product in large number, so at that time you require to access a go down, because same type of product in large number is not available in the small shop. Yes, so definitely at that time you need to go to a go down and pick that product and give it to the customer. So same stuff is applicable over here. So every time, that is nothing but we can say heat ratio. What is heat ratio? Means out of 100 times, 90 times you are getting your data from the main memory. So access time would be fast. But if you talking about 10%, remaining 10%, in that case it means that data is not available in the main memory. So we need to go to a secondary memory and fetch that data and give it to the CPU. Yes, but uh, that possibility is very rare. Yes, so according to this phenomenon, we can achieve this criteria. So let us compute a small example so that you can understand more what is heat ratio and what is average access time, and how we can reduce the average access time with the help of this memory hierarchy concept. So for example, if a main memory access time is say for example 10 millisecond, we have 10 millisecond, and secondary memory access time is 100 millisecond. The difference actually practically the difference is very large, but for ease of understanding I have taken this value. Yes, so because the main memory access time is too small as compared to the access time of secondary memory. Yes, so and heat percentage is given, it is nothing but 90%. And if you want to calculate the average access time, how you can calculate it? So average access time is equal to 90%, means heat ratio is given. So 90% means what? 0.9 multiplied by, means 90 percentage, or 90 times you are getting that product from the local shop. Yes, or we can say in the case of your memory, we can get that data from the main memory. So 0.9 multiplied by 10 plus, if that data is not available in the main memory, so remaining 10%. So 0.1 multiplied by not only 100 but also you need to add 10 also. Why? Because if the data is not available in the main memory, so definitely the penalty you need to include of main memory. So that is the reason why I have added 10 plus penalty of secondary memory, which is nothing but 100 millisecond. So I hope it is clear. So 9 plus 11 is equal to 20 milliseconds. So if you are considering same example by having only secondary memory, so definitely the access time would be 100 millisecond. But if you use this concept of memory hierarchy, yes, so the access time is reduced, and this value is nothing but 20 millisecond. So you can see the difference, 100 milliseconds and 20 milliseconds. So in this way you can reduce the access time by having the large size of memory and less per unit cost. Yes, So I hope it was clear to you. Thanks for watching this video. See you in the next one.